All right, welcome back. Hopefully you understand that we're into lesson 10.1 and we are to the point of the year where we start putting together all the things that we've learned all year long that we used in chapter 8. So hopefully you understand that we're going to be using things like sine, cosine, and tangent to find missing angles as well as finding missing sides. Okay. And we're also going to be using things that we've done in the last chapter we just did, being able to use parallelogram rules, triangle rules, and knowing things that are congruent and equal to each other. All right, so a couple of the key vocab words that you're going to have to know for this particular chapter. One of them is an altitude. And hopefully you remember that an altitude looks like that. An altitude is also known as two perpendicular lines. Okay? And you're mainly looking for this mark right there. That right angle will connect what we call our base and our height. So many of you are using the synonym of height and altitude, just like on a plane. But the idea is making sure that you understand you're looking for this mark so that you can see the numbers that you are going to end up using in your math problems. As you know, in geometry, they usually give you way more information than you need just to see if you can pull out the stuff that you need from the things that you don't. So what are some popular misconceptions? Well, the first formula we do is one that you've been doing since probably third grade, which is the area of a parallelogram. Now, most of you will want to call that a rectangle, but remember, it's not a rectangle unless you have the right angle marks. Okay. So if we do that, we know that one of these is the base, one of them is the height. So we can discuss it as area equals base times height. You just simply plug it in, you get area equals 3 times 6. Now, as we go through, we have about 6 area formulas that we learn. Remember, you don't have to memorize any of them, but through use, you'll end up memorizing them. You don't have a whole lot of choice, but you do get a reference sheet. The big thing is remembering the other formulas that you need to be able to find the missing pieces that you have. So here is a trickier type question. So here we have a parallelogram. Okay, and in this picture, it looks like it's on the outside. All right, basically what they're trying to tell you is that these two pieces are where you're going to get your altitude from, or your height. Okay. And the one that it connects is going to be your base number. So in some pictures, they will go as far as writing 3, 2, and 7. All right? And when we look at this picture, many of us will want to do 3 times 2 because I've just told you that this connects the two numbers you're using. They're giving you this number as a distance that's not needed. Okay? The only two you need is 3, and then this imaginary line is connecting it to the base, which is 7. Okay? So then you would just do area is equal to 3 times 7. Now, I know most of you are like, oh, this is really, really easy, and it's supposed to be. That's why it's 10-1. So please, you should be confident in the work that you're doing right now, but it will get more difficult as we keep going on. All right. So concept-wise, the area of a shape is the area of a shape, regardless of if I move the shape. Okay, so let me explain this to you. If we were in a Word document and you put a square or a rectangle on that Word document, most of you know that if you clicked on the picture, you could grab the corner and drag it one way, drag it another way, and it changes the orientation of the actual shape. Okay? What I'm saying is if we take this original shape and I were to tilt it more or stretch it out a little bit more, the area inside would still maintain the same number. It would just look different. So when you measure things from different sides, it doesn't necessarily mean that you're going to get different numbers. It means you're going to get these same numbers. Okay, now I know I can probably see in your eyes, most of you, if you were in the room, that you're completely lost at this point. Okay, so we're going to do a sample problem so that you understand what I'm talking about. We're going to look at a shape, and I'm going to give you two different dimensions. And then I'm going to give you another two dimensions of the exact same shape. Okay, so we're going to go like this and like this. And finding the first area is usually never too difficult. Okay. People go, oh, well, the area of this shape is easy. It's 8 times 2. Okay, where it gets difficult is when they add in 5, not 8 minutes. Is where they add in a second set of perpendicular lines. Okay, so they'll add another line to this, and they'll put it, let's see, we'll extend this base, and they'll do this. Okay, and they'll tell you this measurement here is let's see, 3 or 6, excuse me. I said 3 and wrote 6. Okay, so now you're doing 8 times 2, which was 16. But they gave you two other measurements that they wanted you to find. They wanted you to find the other base and height. Now, the reason it looks different is because it's two different measurements connected differently. It doesn't mean that the area has changed any. Okay, it's just like if they had shifted the figure. All right, so then you would have to set the two area formulas equal to each other. Well, in one area formula, you had both numbers. You had 2 and 8, which gave you 16. In the other area formula, you're only going to have one of the two numbers. Okay, 6, and then for this argument, we'll just call it h. It doesn't matter what your variable is. Okay, so now you have to put the two areas equal to each other. And you'd have to solve for the missing piece, which means you'd have to turn around and divide by 6, and you would get 16 divided by 6, which is an ungodly decimal, which would be, for our sake, we'd just be 2 2/3. Now this is why you have a calculator that does fractions, so that you don't have to do any thinking. All right. I'm going to give you one out of the book. We're going to look at it together. Okay, so here's another one. And again, this picture represents two different measures. Okay, you can see you have one here that's 9 inches, and it would be multiplied by what other measurement? Hopefully you know it would be 13, okay? The two things that are connected by the right angle mark. So it would be 9 times 13. Then they give you another measurement here. They give you this measurement, 9.4. And we're missing this one here. Okay, so it's inside of the shape. We're looking for this height. Okay, so what's supposed to happen is that this number here. Okay, so here's got it problem number 1. Go ahead and pause the video, work the problem, and then we'll go over the answer. Okay, here we go. This is got it problem number 2. Pause your video, work the problem. Here is got it problem number 3. Again, pause the video, work the problem. And lastly, here is got it problem number 4. Again, pause the video and work the problem. Okay, so here we go. The answers for the got it. Please make sure for you to get credit for your work that you do make sure that you always write out the equation. Remember, we're going to have multiple equations, and you're going to have some problems that use multiple equations to get your answer. So the work I need to see has to be at least writing out the equation and then plugging in the numbers. And in the case of the first problem, it was relatively easy. It would be 9 times 12, and then your area is 108 centimeters squared. Remember, this is the minimum I need to see. If I just see the answer, the book has the answers. So I'm expecting you to show me the work and that you at least know what equation to use. Usually the mistake in this chapter is picking the wrong equation. All right, problem number 2, it involves 2 different measurements that are supposed to be compared to each other. Hopefully you know what corresponding means, and you should be doing 2 area formulas. Remember, the area of a shape doesn't change, just the dimensions do depending on how you measure it, okay? So you would have 2 area formulas and you put them equal to each other because they're both parallelograms. It's the same shape. Okay, if it was 2 triangles and we measured 2 different measurements, we would do the same thing with 2 triangles. But here you have 15 times 9. They told you that they were corresponding and that they matched. And 18 and H would be the other 2 that are corresponding and match. You put them equal to each other, you do the math. Okay, you get 135, divide by 18, you get 75H. Notice this one is not in units squared because this is a measurement. This is area. Okay, area is always in units squared. There are going to be times on a test you're going to see 108 centimeters and 108 centimeters squared. You have to know the difference between the area answer and a length answer. All right, problem number 3. Area equals 1/2 base times height. Again, not a really tough one. Okay, relatively easy. Making sure you write out the equation. Second step is plug in the numbers. Okay, and then you can give me the answer, which in this case is 2.5 inches squared. Most of this involves you just writing. Okay. Then problem 4. Problem 4 is where we had 2 shapes. So when we have 2 shapes, what do I tell you? Please make sure you write out both equations. So I'll widen this out so that you can see you should have both equations written. And in this case, hopefully you drew it out because they didn't give you a picture. They gave you a picture, but they modified all the measurements. So for the triangle, your base and height should have been 8 and 12. And then in the parallelogram, it should have been 12 and 12. You do the areas for both of the problems, and then you add them together. That's how I get 192, again, inches squared. Making sure that you double check your units. Many people get the right number, wrong units. All right, good luck on the work. It is supposed to be multiplied by this number, and it would equal the same area as 9 times 13. Now this is an example out of the book, and one of the reasons I'm showing it to you is so that you understand that this shape hasn't changed. The area inside that shape is the area inside of it. The only thing that's changed is where they're measuring from. Okay. So now instead of measuring the height and using this as the base, they're now using this as the base and this is the height. Okay. So we'll go back to the paper and I'll show you the math. We know that it's 9 times 13. Okay, so that's one of the area problems. And the second area problem would be 9.4 times x in this case. All right. So then we go through the math. 9 times 13 is 117, which is equal to 9.4x. Divide both sides by 9.4, and you're going to get approximately 12.4. Now I will tell you that we're going to round to the 10th most of the time, okay, just for simplicity reasons. So unless they tell you something different in the question, which can happen, we're going to always round to the 10th if they don't tell us. All right. So there are times that they're going to give you 2 different bases and 2 different corresponding heights. Hopefully remember what the word corresponding means. It means to match, correct. All right. So let's see, other than the simple multiplication problems, they also talk about the area of a triangle. So the first 2 formulas that we're learning is the area of a parallelogram, okay, which is area equals base times height. And then area of a triangle. And the area of a triangle is half base times height. Again, we're still looking for this symbol. So that means most of the triangles we have are going to have right angles in them, which makes them right triangles. Hopefully you understand that's why we're going to be using things like 30, 60, 90, 45, 45, 90, sine, cosine, and tangent. Okay? Remember, those are all shortcuts. You can use sine, cosine, and tangent all the time if you wish. But 30, 60, 90, and 45, 45, 90 are shortcuts. All right? Again, not a very difficult concept. Once again, it's something that you've done all through middle school. The formula hasn't changed any. The only two words we've really gotten rid of are length and width. We call them base and height now because it's two-dimensional. Right? When we deal with length, width, and depth, we're usually talking about a three-dimensional shape. All right. Let's see. The culmination of this, meaning when we put these two formulas together, is when we start going from simple pictures to complex. Okay, and hopefully remember what the difference between a simple picture and a complex picture is. A simple picture is where we're dealing with one shape or figure at, one shape at a time, whereas a complex deals with more than one, so that when they are next to each other or two pieces of the same attendance, right? And notes, can you take that with it? We're talking about two pieces of two different shapes. So many of you have always seen this picture before, and they say, what is the area of the shape or shapes? You'd find the area of one, you'd find the area of the other, and because they are next to each other, you add them. Okay? When we have shapes that are inside each other, we subtract them. So it's finding the shapes, using the formulas, and then adding them together. All right, so let's take an example of one. And I'm going to do this and give you the measurement at 8. And this is 6. So our two formulas, and I will tell you to get in the habit of writing this down all the time, because most of this becomes math that you will make arithmetic errors on, not the fact that you don't know how to do the math. Many of you try to do it in your heads, and unfortunately it does not turn out well. All right, so here we have an altitude of 8. This is for our triangle. And we do have the base. The problem is they didn't give it to us on that shape. How'd they give it to us? Hopefully you remember the chapter we just did that dealt with squares and rhombuses, that these markings mean that all of the sides of this shape are 6. So in other words, they did give us the base, they just didn't put it on the picture, they put it over on the side. Okay. So the area of the triangle is 1/2 8 times 6. Then we do the area of the square. Okay, and this is the formula for the area of the square. We can go ahead and put 6's on all the sides, and we know that the area of the square is 6 times 6. Okay, so we get 6 times 6, which is 36. 1/2, 8 times 6, 6 times 8 is 48. Divided by 2 is 24. Then we add those areas together, and you get, correct, you should have gotten 60. Now, habit you want to get into. This is 60 units square. You're going to have times where they give you multiple choice answers, and they will have 60 units, and they will have 60 units squared. And many of you will go, oh, they got the same answer twice. These are not the same answer. This is always the answer that area is in. Area is always in squared units. Right? If you have regular units, that's a distance or a length. That's never area. And then, of course, who can tell me what cubed is? If squared is area, then cubed would be volume, correct. And that would be what we're going to be learning the last two pieces of geometry, are how to use area, surface area, and volume. All right. Now, believe it or not, as you move up through your maths, the concept or being able to find area and volume doesn't change. Area is area and volume is volume. What changes are the types of shapes that you're dealing with and the complexity of the math. It's still the same concept. Conceptually, you're doing the same type of math. It's just you're doing way more abstract adding and subtracting. All right, and that is it for lesson 10.1. Good luck on your assignment. Remember, if you have any questions, your best bet is to do the lesson check. And once you do the lesson check, come into class, check your answers. It is supposed to be part of your notes. And then when you come in, you can go ahead and finish the rest of the assignment. And we will see you on Wednesday. All right, thank you.